Hey everyone, Mr. Andrew here. Today we're going to talk about periodic trends. So, periodic trends are just trends in the properties of the periodic table that we can observe based on where elements are positioned on the table. When we're talking about periodic trends, a lot of times we separate them into two different types, what we call period trends and group trends. Period trends are as you move from left to right on the periodic table. Okay? So, this is the period trend. Group trends, on the other hand, are as you move from the top of the periodic table down to the bottom. Okay? Now, for periodic trends, let me add a little right here. Group trend. So for periodic trends today, we're going to be focusing on three different types of trends. Okay? We're going to be focusing first on atomic radius. Okay? Now, the three trends that we're talking about in total, and we're going to color code them. We're going to talk about atomic radius, sometimes called atomic radii. We'll talk about ionization energy, and we're going to talk about electronegativity. Okay. Now, these trends are actually all tied to the exact same phenomena. Okay. So let's talk about that a little bit. And first, let's focus on the group trends. Okay. When we're talking about the group trends, we're talking about as you move down a group on the periodic table, straight from top to bottom. Okay. Now, what's important to know, or what's important to understand, is as you move down the group, you are increasing the period number. Okay. If you look on the left side of the periodic table, many times you'll see this will be period 1, next row will be period 2, period oops, that's not 3, 3, 4, 5, 6, and 7. Okay. And you may recall from Unit 1 that each one of these period numbers represents an additional energy level. Okay. And energy levels are basically rings around the nucleus, right? So if this is our nucleus right here, the first ring will be the first energy level, second energy level, third energy level, whatever. Okay? So, if we're talking about atomic radius, okay, atomic radius is just simply how big is an atom. And we measure the size of an atom by using the radius, the distance from the very center of the nucleus all the way to its outermost energy level, its outermost electron. Okay, the same way that we measure the size of a circle most times. So, naturally speaking, as we go down a group, because we're adding more and more rings, and the rings are added from innermost and we work our way out. So, this is the first energy level, second energy level, third energy level. As you move down the group, we have 1 energy level, 2 energy levels, 3 energy levels, 4 energy levels, so on and so forth. We're adding more rings, and as a result, the size of the atom is getting bigger. So, the group trend for atomic radius is that the atomic radius increases. Okay, I'm color coding these so that way you can see it increases as you move down the group. Now, let's talk about ionization energy. Ionization energy is defined as how difficult is it to pull off an outermost electron from an atom. So, because electrons are placed from the innermost ring until that ring is full, and then it works its way out, the outermost electrons, or the ones being added, will always be on this outermost ring. Because the electrons are being held to this atom by the positively charged nucleus, the further out the electron is, the more difficult it is for the nucleus to hold on to that electron. It's kind of like two magnets. When you have a positive magnet, like the nucleus, and a negative magnet, similar to the electrons, if you put them close together, they can stick together really well. But if you put those magnets on either side of a room or either side of the planet, their ability to stick together is a lot lower. So, similarly, because as you go down the group, you're increasing the number of rings and making the atom bigger and bigger. As you go down the group, you similarly lower the ionization energy. You lower the amount of energy that it takes to pull off an electron because the positively charged nucleus can't hold on to those electrons as well. So the group trend for ionization energy is as it goes down the group, as it goes down the group, ionization energy decreases. Okay. Lastly, let's talk about electronegativity. So electronegativity is essentially how well can a given atom attract or draw electrons towards itself. Okay, it's a little more complicated than that because it technically is how well can it attract electrons within a specific type of bond. However, for electronegativity and for simplicity's sake, we're just going to focus on explaining it as an atom's ability to attract electrons. So this is going to follow a similar pattern as the other two, because as you move down the period, or down the group, I'm sorry, your outermost electrons are getting further and further from the nucleus. That nucleus is less and less able to attract those electrons. So similarly to ionization energy, electronegativity decreases as you go down the group. Okay? Now, all three of these are basically for the same reason. As you go down the group, the atom is getting bigger because you're adding more rings. The ionization energy, the energy it takes to pull off an outermost electron, is going to decrease because those electrons are further away from the positively charged nucleus. And the electronegativity is also going to decrease because the nucleus is further away from the electrons it wants to attract. So it's not as good at it. Okay. So those are the group trends for these three. But let's look at the period trends. Okay. And for the period trends, we first have to understand some basics. Okay. You may remember from previous units that as you go across the period, or as you move like to the next box over, you increase the atomic number of that given element by 1. So this is atomic number 1, atomic number 2, atomic number 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. Okay? Let's focus on period 4. Okay? Actually, let's focus on period 3, okay? Because you're increasing the atomic number, and the atomic number is defined as the number of protons, as you increase the atomic number, each time you increase it by 1, you're increasing the number of protons by 1, okay? So, let's say you had an atom, right? This is our nucleus right here, okay? And then this is our first energy level, okay? If we look at atomic number 1, it's going to have 1 proton, and it's going to have 1 electron. I'm going to represent an electron with a dot right here, okay? Because this proton is positive and this electron is negatively charged, they're attracted to each other. So the electron stays in this like relatively simple orbit, okay? There's other reasons why it's maintaining this orbit, but the reason why it doesn't just fly away is because it's attracted to the proton. Let's then look at atomic number 2, okay? Atomic number 2 is going to have 2 protons and 2 electrons, okay? Now, this first energy level can fit 2 electrons, but critically, did you see how this second electron that I added was placed on the same ring, on the same energy level? Because these are orbiting around the nucleus, this electron isn't placed any further away from the nucleus than the other electron. However, the number of protons increased. And because the number of protons increased, the positive pull from the nucleus is actually stronger. We call this the nuclear charge. The nuclear charge is just the positive attraction from the nucleus. And so as you go across the period, and as you increase the atomic number, the nuclear charge is getting stronger, okay? So let's go back to our period 3 that I mentioned earlier. Okay, let's go ahead and erase that. I'm not going to include the negative signs anymore. Hopefully you guys understand that all of these electrons are negatively charged. So here's our second energy level. Here's our third energy level, okay? Now, the second energy level can hold 8 electrons. So I'm going to just go ahead and add 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, we're looking at period 3. So we're going to look at the third energy level. Now, for the purposes of this activity, we're going to say that the third energy level holds 8 electrons. It can hold more than that technically, but we're going to focus on it being able to hold 8. Okay? So, if we had this first element right here, okay, this first element on the periodic table in group 3, it would have 2 plus 8, that's 10, and then 1 additional electron for 11 protons. Okay? So it would have a nuclear charge of plus 11, and it would have 1 valence electron. Okay? Now, let's go across the period, because we're looking at the period trend. The second one in this row would have 1 additional electron. I'll go ahead and draw it right here on the bottom. But the nuclear charge would now be 12. So this electron that we just added, and the same with the original one, they didn't get any further away from the nucleus. But the positive pull from the nucleus got a little bit stronger. And like 2 magnets, we're going to keep using that magnet analogy. The stronger the magnet, the more it can pull on these negatively charged electrons. Really strong magnets can slam together to the point where they can like destroy objects or make sparks and things like that. So what we're doing is, as we move across the period, we're actually making this nuclear charge, the positive end of this magnet, stronger. Okay? Let's keep going. Let's go to the next one. The next one right here would add one more electron for a total of 13 electrons. There's 3 in the outer shell, and it would have a plus 13 nuclear charge. So as you can see, these electrons all keep getting added to this outermost ring. They're not being positioned any further or closer than any of the other electrons in this outermost ring. But the consequence of that is the nuclear charge is getting stronger. So remember, when we talked about the radius for the group trend, we talked about atoms getting bigger because we're adding more rings. We're not adding more rings here. We are just putting the electrons in the same spot. But because the nuclear charge is getting stronger, it's pulling this whole ring of electrons ever so slightly closer. So the result of this is that as you move across the period, the atomic radius decreases. Now let's look at ionization energy. Remember, ionization energy is how much energy does it take to pull off an electron. What makes it harder to pull off an electron? If the nucleus is a stronger magnet. Stronger magnets are harder to pull apart than weaker magnets. So as a result, as you go across the period trend is ionization energy increases. Lastly, electronegativity. Electronegativity is how well can an atom attract electrons. What makes an atom good at attracting electrons? Having a more positive nucleus to pull on those negative electrons. So, as the nuclear charge increases, as you go across the period, the electronegativity also increases. So, as a result of this, many times you'll see these trends represented as arrows kind of going across the periodic table. So, let's add those arrows. Generally speaking, electronegativity, or I'm sorry, let's start with atomic radius. Generally speaking, atomic radius increases as you move from the top right down across to the bottom left. Okay? Because again, it gets smaller going this way, so that means it gets bigger going this way, and it also gets bigger this way. So the smallest atoms are in this upper right corner, and the biggest are in the bottom left. If we're looking at ionization energy, it increases as you move across the, or as you move up the group, right? Because it decreases as you go down the group. And it increases as you move across the period. So that means the elements with the lowest ionization energy are in the bottom left, and the highest are in the top right. Lastly, electronegativity. Because it decreases as you go down a group, it means it increases as you go up the group, and it also increases as you go across the period. So similar to ionization energy, the lowest electronegativities are in the bottom left, and the highest are in the top right, like that. So hopefully this helped you out. Feel free to come by and see me anytime if you have any more questions on this topic.